So hello, my name is Kimon Onuma, and I have Ryan Gear from SketchUp here with me as well. I'm from Onuma Inc. And we're going to be talking about a healthcare hack that we've been working on. This is for the BIMStorm healthcare hack. It's a little bit unusual because I come from the building industry, and owners, huge owners like the Department of Defense and VA have massive amounts of data that's typically locked up in PDFs and paper documents, and this is the norm of operations today. Basically, you take information, you jam it into a CAD or a BIM file, you save it as a PDF or some other format, and you place it on the website, and you expect the design teams to be able to make decisions with that. So our hack involved, it's multi-dimensional because first of all, we wanted to make it as realistic as possible. The first step is, in these design projects, there's obviously designers involved that are making decisions along with the owners of what goes into a healthcare facility. So it's producing massive amounts of, here's a hospital, here's an exam room. And what we did is we, on the Onuma side, have been working with these owners to convince them to open up their data in a web services format as one way to do it. Basically, put it on, instead of putting it in a PDF file, put it on a server and make it accessible to teams. And this has been going on for 2 years. So there's been 2 years of preparation of explaining why and what the benefits of it are, and saying that there's a community out there that can use this data and interact with it and create great applications like we just saw. So that was step one. The milestone was that in the last month or so, they've actually finally opened it up. So that's why we decided to jump into this hackathon. So this is the time to actually show how we can connect to it. So this is not just a single tool here that we're showing, but we're showing a collection of things, some things that have already been developed in the past, but the hack, part of the hack was, let's start connecting these tools together and use the owner's data that's coming from their facility database. It's called SEPS, which is available as a SOAP web services, and there's also RESTful web services. And it's about equipment and spaces. Equipment and spaces drive hospitals. They have 200 million square feet of hospitals. A typical million square foot hospital has a couple hundred, 2.5 million data points. I'm a space, I have equipment in it, I need this much electricity, I need this many air changes, so it's pumping just data just constantly, and the designers are making those changes to it. So we had access to, and we actually guided them towards setting this up, this web services from SEPS, which we convinced them to make it 100% public. And the reason it's public is because it's not an actual project yet. It's their requirements that ends up in a project that then goes into BIM and CAD applications for design and construction. So we said it makes all the sense in the world to tell us how you call things and what you call equipment. And once you have access to that, things can start to happen. So, for example, we said, okay, if we have this data available, what happens if we actually set up a whole workflow scenario end to end? We're starting to design a project, and we want to pump the data out there and have design teams to make decisions with these objects. There's three-dimensional, BIM objects associated with the data as well. And teams like Val Beatty, who are here, we actually interacted with them and said, we have data that's coming out of a project about quantities of equipment. What can you guys do with it? You hooked into the server that was here, and then you reacted to it and posted it. And some of it was automated, and some of it was manual, so it was kind of an in-between thing, but essentially it's data that's coming automatically out. What can you do with it? So that's one thing that happened. We were able to associate a cost that drove the cost of the project. This team was actually Bluebeam. Bluebeam was here, and they were wondering how to get involved in this hackathon. We said, well, we have the model coming out of the server. It's a model server that's pumping the government data. Here's their spaces and equipment. What can you do with this if you take it into Bluebeam and make a comment on it and post it back? So we didn't make it all automated. Some of it was a manual, kind of let's take it out and do something with a PDF and mark it up and put it back, which was great. The next team was a team called Building Catalyst. And some of these teams just jumped on just even a few hours ago. We had one that jumped in and said, hey, we have this, and I'll show it to you at the end. Adita showed how they automated the design process of a clinic using this data. So we set up these teams, and they're virtual outside of here as well. And that's the difference maybe with our team. We have people here in the room, but we also have design and architects and software developers outside of the room all over the world, essentially, looking in on the web services as they're being developed and decisions are being made, and then reacting to that either with their knowledge or with their application. So here's where we plug in, and we can pull data from the web service that you have about the requirements and give you back, for example, cost estimating and other information from here. And that's one of the messages we had given to these owners from a couple of years ago when we started this, is if you start exposing your data like this, then you can start making automated or semi-automated processes all the way into BIM, into design, and into fabrication. So it's really endless. So here's one team, Design Atlantic, and we identified a site on Friday here at UCLA. We say, well, there's a nice big green field there. I don't think UCLA really cares about football too much, so we'll go ahead and put buildings on the field, right? We call these train wrecks. We like these kind of, what about this? If you throw it out, then you can get a reaction, then you have to move the building. But what happens as an architect, I know this, in the building industry, you make decisions, and people don't see it for a month or 2 months or even 2 weeks, and the project progresses, and all of a sudden you have to backtrack. So exposing those decisions and making them accessible to many levels of users, regardless of your skill level, is critical, because not everybody's going to be a BIM expert, is one example. We want to be able to give the doctor a view of his room and say, here's data coming out of the government database that says you need this boom arm in the ceiling, do you want it there? They typically see it as a list, but now we're able to pull it all the way into BIM and show that. So that's what happened with this building. Everything that you're seeing from here on forward is the live data that we have, that we opened up the pipeline to on Friday, being pumped out to these teams that did stuff with it either automatically or semi-automatically. And Design Atlantic essentially focused on a project where they landed a building on the UCLA site. Grabbed on the left side is what came out of the CEPS database that I mentioned earlier. Essentially, we opened it up and said, here's the requirement model that an owner wants this type of exam rooms and these types of spaces to go into an existing building or not. Design Atlantic went ahead and put it into this. In this case, they use the Onima system and ArchiCAD and Revit. I'm not sure exactly which other BIM application, but the tools don't really matter. It's a fact that the data is moving regardless from the owner's database into these tools to make decisions of how does that fit in that room. And then, this is actually Onima system, that's our application, but basically he plugged that report coming out of the building into a cost estimate and an early energy report. And then we said, okay, what happens if you take this out into iPad applications? So there's these apps that already exist that we're latching on to the data that's coming from the government server database. So this is live government requirement database, data coming out of in this case it's SOAP web services going into the Onima system and coming out as a RESTful web service that then was consumed by other applications in this process. This is actually another interesting team called Innova that has access to the government application. They went in on Friday, put in their requirements for an actual hospital, because they have access to the application. Once they put it in, it pumps out data. That data was then taken into the Onima system and it was automatically generated these, okay, in that database that Innova has access to. And CEPS have pumped out the requirements for a hospital exam room, and they put their comments inside the other system, which then fed up through web services into our view here, which then pushed it into BIM, which then pushed it into SketchUp, into Revit, into Navisworks, into Google Earth, and things like that. So it's basically trickling out from one source of truth to that view of that end user there. Then they had the requirement model, and we used this building. This shape is going to be familiar to you. It's a U-shaped building. We said, what happens if we rip out all the studios on the second floor and make a clinic up there? Because the government wants to put a clinic here. These kind of rapid scenarios, and then the color coding that you're starting to see are pieces of data that says, owner asked for this. Now we're seeing designers making these changes in real time. So once you have the data of the owner accessible, then you can start querying it and saying, what's the delta? We have a GUID for a piece of equipment. Where's that equipment? Somebody deleted it in the BIM or the CAD file. This gives access to designers to be able to have these kind of dashboard views into BIM, into CAD, into GIS systems with owner data feeding into it. This happened all since Friday, actually. So the other critical thing that happened, there's some part of this that we've obviously been prepping for a lot of this before, but things have happened even while we were here. So for example, SketchUp has a plugin that we open sourced before we got here from the Onima side, and the SketchUp team ran with it, and they were adding new functionality to it even up until this weekend. They've been working on, let's add new functionality to it, and we had discussions about how do we get the Innova data into SketchUp. This is a SketchUp model that pulled from our server, that we just pulling from the government server and feeding the objects and the spaces, and the red objects have meanings in here as well too. It's basically an object that might be missing, or it's the wrong size, or it's not in the database. And then we said, what happens if we take all of this system and we sit down a 15-year-old Matthew Gear, who's Ryan Gear's son, who's never touched BIM or any of this, and said, go for it and build this room here based on the government requirements. So he was taking objects from the meeting room from a healthcare facility and laying out these rooms with these objects. So if you click on these objects, they actually drill all the way back to the original data that came from that CEPS database that we were talking about earlier. And he built the room and then took it out to SketchUp and to the Onuma 3D iPad app. If you go and click on these chairs in the iPad app, for example, it's pulling attributes from a government database that originated the requirements. And then there were other teams that were making decisions, like Michael Skarmak and Design Atlantic were saying, well, what happens if we have to put a corridor here? So the dynamic here is that this data just doesn't sit there and exist and we just can use it. In this case, there's tons of architects and engineers and owners making decisions about moving and pushing and pulling. And that's the most interesting thing to me from a developer's perspective. If you're a software developer and you can actually access this and do cool stuff with it, it's almost like having a Google Earth and a Google Map and mashing up information, but in this case it's real facility data that owners saying, here's what we want to build. What can you do with it? Because the status quo is in the industry today, all this stuff is just really manual and disconnected as far as being in real time. So this is their building on Google Earth, again coming from our server with a web services network link from Google Earth to the Onuma server back to the government server, and then the decisions that were being made by Skarmak on the design. He also took it into IFC, so it was basically this data comes from the government server, starts trickling out and filtering into different applications. Design decisions are made along the way, and then different formats are being output into different BIM formats, in this case IFC into ArchiCAD from SketchUp. Here's a SketchUp automatically generated model landing on the site. Discussions were happening as this was working. As these edits were being made, we had a web service open to this group here, and we have the URL here. So if you go right now and you look at the RESTful web service, it will give you a list of equipment that was just being changed until an hour ago. And it will change. If I go in there and say, well, I need a bigger room or a smaller room or whatever, it's pumping out data as the designers are making decisions with, and still being in alignment with the government data. This is HFR design. Also doing the same thing, basically taking it, landing on the UCLA site. They gave them a mock-up scenario, design a project around this site, drilling all the way from the multi-building level all the way down to the room. And they did not have to type any name of equipment or any name of space because that came from the government database. That's a huge problem in the AEC industry. What do we call things? Because owners are not consistent about what do we call spaces and equipment. This owner has a database that says, here's what we call medical equipment. Here's how we call a boom arm. Here's what we want the characteristics of the room. Now you can use this to actually work with the data. This is an interesting view. This is a UCLA campus with a mashup of all of the projects that were happening over the weekend. There's probably a couple million square feet of stuff just carpeted throughout here, and I'll be slicing and dicing this a little bit more. This view is actually, it was originally 1,200,000 square feet. We had a webinar last week introducing that we were coming to the hackathon. We had over 300 people online. We gave them access to a simple URL and says, go push this button, request a dental clinic. Their request is, I need a dental clinic, pushed it into our server, which grabbed data from the government server, pumped out requirements. So if you open up any one of these boxes, it's packed full of equipment. Each one of these is a department. Emergency department, dental department, and then we carpeted it on the UCLA site. So now we have to design this. Where are we going to put this on the UCLA campus? That was happening this weekend. And then we noticed that there's a VA site right across the street here, West LA VA Center. So we actually took that this morning. This happened this morning. So let's pull all those carpeted spaces and stack them up as a building here in Google Earth. From Google Earth, there's a network link. This is about an 8K file for about 500,000 square feet that's going back to our server. It's going back to the CEP server on the government standards and pushing it into Google Earth. And the designers, as they're making changes on our server, would actually see the changes over here. And all of this is the reporting at the same time. So saying how many square feet, what's the cost, how much equipment. So all this data, tons and tons of data just being generated just by that simple request of we need a new hospital in West LA. Cost and square footage coming out as a change. This actually happened this morning. A couple hours ago, we were basically jamming everything together and say, let's put this in the West LA VA Center. 4D pipeline. This was a huge win. This happened this weekend. This is our app, but it's working on Revit, and Navisworks, and we're working on SketchUp as well. What you're seeing here, and I'll show this live in a second as well, is you click on a piece of equipment, it pulls up the VA data. Then it says, oh, I see an ID for a piece of equipment, and it pulls up the Atania data. Atania is another group that's part of this BIMStorm that has a huge database about medical equipment. Because you need a boom arm here, we have information about that boom arm, and you can keep on drilling down to cost and warranty information, whatever else. So the designer has the choice. This is the Atania interface. So if the user on the Atania side is making changes. We worked with them, kind of prepping for them last week. So we're working on this hackathon. Can you guys open up web services? Kind of work with them together. And then on Friday, opened it up and then linked the Revit, Navisworks, and the SketchUp work that we're doing next, which is the next step. Their data actually linking into that. So this happened this weekend, essentially. The NUMA system was already there with the data, the SEPS data from the government server, the Atenia data was opened up, which fed into Revit. So in Revit, we do not store any data that's coming from a server, in this case Atenia and NUMA, about the equipment. The same thing happened in Navisworks. This happened in about 30 minutes, actually. Once we had it in Revit, you open the plug up and you have web service running in Navisworks. And we're working with SketchUp next, which we think is going to be a relatively easy next step to actually open up Atenia there as well, too. Here's the view in Revit, Navisworks with the Atenia data in it, feeding in from the NUMA server and the SEPS server, and so 3 different servers basically feeding into the view here, and then the same thing in the NUMA iPad app. It's kind of dark. Well, actually, I could probably show it. So if we go, all of the data that I talked about, now I'm on the iPad, and I want to be able to find this piece of equipment. And this equipment, there it goes.
You're not projecting right now.
Oh, it should be projecting, sorry. Okay, let's try that again. So this is this building that we worked on with the teams. Built this room with Matthew earlier. And this is not, grab on, I can probably do this. Sorry, I'm taking a little bit longer time, is that okay?
That's fine.
Covering a lot of it. Tell me when to stop, I'm almost at the end here. But, so essentially what's happening here, I'm on the iPad. I know nothing about BIM, I know nothing about facilities, I know nothing about data, but I want to find information about why is that projector not working. What we had set up and teams were, this is not working out. So the projector really isn't working. Maybe I won't be able to show this.
It might be the resolution of that.
Let's skip it. Essentially, you can come and see this later on, but basically the iPad grabs the QR code that was in the database that was built on the fly when we put that projector in the room. See there? And then we scan the code, it opens up the plan, the BIM in the iPad, it finds that projector, it grabs the Atenia data that we hooked into on Saturday and says, here's the specification of that projector, the Sony projector, blah, 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 whatever. This happens for all the spaces that we showed earlier with the equipment. Every single one has this information associated with it. So the last thing, while this was all going on, while we were designing and moving spaces and everything, we said, what happens if we also, and this web application already existed. We did not build this one over the weekend, but we hooked into the data that was coming from the Atenia and the SEPS server here. So we have live work orders coming in and saying, hey, this piece of equipment's not working, whatever, with a mobile device. It goes and grabs the pull down is actually coming from the server, so we don't have to find the name of the space, it knows where you're, all that stuff. That's what basically our message to the DoD and VA when we work with them is, listen, there's tons of great applications out there that you can just plug into, and there's great developers that can create solutions, because today, what they do with their legacy applications, every time they want to add a new pull down, add a new field in their application that was built in the 90s, it's $500,000 for each new pull down they want to make. We said, this is nuts. You can build stuff over the weekend in a hackathon that basically wipes away anything. There's nothing special about this mobile work order. What's special is that the data in the background, you don't have to reinvent the wheel. It's coming from their server and saying, here's what we call it, here's what we call that projector. And the Atenia saying, here's when that projector was installed, and other information beyond it. So facilities management, design, and construction is incredibly complex, as we all know. But the complexity can be broken down into modules like this that makes it approachable, and we can build really exciting stuff. And what we're showing here was not just a weekend hackathon for us, because there's going to be ongoing interest. If we can get in front of these owners that can fund this stuff and say, hey, we have teams out here that are doing really amazing things, why not use that talent out there? I'm from California too, so whenever I go to DC, I say, why aren't you guys looking and seeing what's happening in Silicon Valley and you're using this technology from the 90s? So part of it obviously is cultural and all kinds of other reasons why, but anyway. So this is some of the results of that. Oh, and this is the last thing. This just literally came in 2 hours ago. There's a group called Aditas. We thought they were not going to be involved with the hackathon. We sent them a note on Friday and said, here's data coming out of the government data. They have a plug-in and they have a whole system, that this is in SketchUp, that takes the spaces that came out from the system and automatically starts arranging them. Aditas does this automatic arrangement and blocking and stacking of spaces, and they go all the way from design into construction and fabrication and installation, but it's for healthcare facilities. They're relatively new group in the last couple of years doing really innovative things, and they basically took the spaces and say, we have rules. They have a rules, I'm guessing here, because I haven't even heard the presentation. I heard part of it before. What I'm seeing here is that it's basically saying we have a corridor here, and we have these spaces that are coming from the requirement, from the hackathon data, and it starts to configure the spaces with these kind of rules that inserted into modules, and that I believe they take this all the way into fabrication as far as installation on the site. So pretty exciting stuff with Aditas, and I want to show a few things live here just so we don't make this all just a PowerPoint thing, but while we were doing all this, and some of you already seen this is actually on the website called sepsbim.org. If you go to the events page, this site is being watched by the government clients and other owners as well. We basically set this up to say, look at all this stuff that's happening. On the events page, the web services that I talked about is available here. So if you click on the web services, this is the actual, this building with that equipment, with that projector, with that information, with the Tanya is all available through there. You can actually hit it and pull the data through a RESTful web service. Very simple, and even has plugins to say, hey, you need a floor plan, configure a viewer. You take this snippet of code, and it's basically like a Google map type thing. You basically can plug it into your application and pull up that floor. So here's this building. You kind of fake the rest of it, but this is this room that Matthew started building the other day. The web service, okay, and then we built a little Prezi that we're going to post this as well. This is kind of an overview of what happened. These are the teams from around the world. So the BIMStorm team was outside of this building, obviously, but we wanted to simulate things happening with engineers and architects and other programmers that are starting to make decisions about what's happening on these projects, and these were teams that were happening from around the world. The most important team, I believe, is a government client that agreed to open up their data. We need to encourage that more, because if you start opening up information, it makes it easier for teams to actually work with it. And all the slides that I showed earlier are also here as well. The live floor plan, whoever was part of the hackathon actually has access to these tools, but you can actually see the floor plans here as you change this online. This is actually our application, but it's the link to the SEPS data and the Tanya data and output to SketchUp. It's all online here. The work order app that I talked about, that's also, you can try it out if you want. It's all linked from here. The request and then the result, if you say I'm in this room and this room is hot, the room turns red because data is driving these graphics. It's not just static files. These applications were built before, basically hooked into the SEPS data that I talked about earlier in the Tanya data. And the last one I should like to show is, here are the teams. We split it up into design teams, designers and developers. We said this needs two sides, the domain expertise about buildings and the developers that can do stuff with data. We want to marry the two together. And then the West LA thing, I'm going to just show you this in Google Earth. This is an 8K file. Google Earth, I'm just going to launch into Google Earth. It's going to go Google Earth, hit our server goes and grabs the latest data from SEPS, pulls it into Google Earth, and starts to basically build that West LA hospital of 400,000 square feet with, I think, $150 million. We put a number of how much we spent. I think it was $147 million this morning. We're basically stacking all these spaces. We're counting equipment. Val Forbeti put a cost to that equipment. We can then extrapolate from that, pull it out into the whole building. It's obviously a first shot, but at least you throw something out there and you get a reaction. Because these kind of projects typically drag on for months, if not years, and all of a sudden you have cost overruns, and it's a huge problem out there with these massive complex projects. But this applies also to even simple projects. So as soon as you can start seeing things like this, then you can start to make decisions with it. Okay, I'm not going to go into that. You can actually try it yourself. We'll send you a link to the network link to that file. The last thing is Google Earth. And for some reason I'm disconnected from the internet now, but that's okay. I'm sorry, SketchUp. So SketchUp does the same thing. Basically, we said with SketchUp, don't go and pull this data and jam it into SketchUp. Use the source data that's coming from these servers. So when you get objects, go and grab these objects. It's in the 3D warehouse, and it assembles the space from the equipment that matches this government requirement. And you can see an exam room like this can be pretty complex. And that hospital that I talked about earlier in Google Earth, there's about, I don't know, 1,000 of these spaces with equipment like this in the space that you still have to obviously make decisions with, but at least you have the pieces in place. So I'm going to pause there. I ran through a lot of material because we have a lot of things happening in this. If there are any questions, we're happy to share any of this, how it's done. We are really looking for other solutions to hook into this, and the government owners, and I'm not the government employee here, I'm basically the consultant that worked with them. I'm not on contract today, I'm basically here on my own, but I know they're looking for other things because they can't solve this alone. So they're looking for the innovation that we see here today, and how do we make this go forward into the next phase. And I know that really exciting things can happen here because it's so much low-hanging fruit, but it's really, the complexity really requires a community like this to solve it.